let's dive right into this in-depth explainer for NCP-MCI 7.5, 4.6 shared containers, whitelists, reserved capacity. Today, we're focusing strictly on how we manage space and access in Nutanix environments. If you are an infrastructure admin gearing up for the exam, you already know this is absolute core territory, so we're going to get straight to the good stuff.
Here's our roadmap for today. We're going to quickly hit on why this matters, walk through the actual mechanics of whitelists and reserving capacity, expose those sneaky common exam traps that catch people off guard, and then lock in the key facts you absolutely need to memorize before test day.
Starting with Section 1, Why it Matters. Let's talk real-world implications.
Look, I know you all live and breathe this stuff, but before we get deep into the weeds, let's just do a lightning-fast baseline on our acronyms so we're completely synced up. You're going to see these all over the exam. AOS is our Acropolis operating system running on the CVMs, or controller virtual machines. AHV is the native Acropolis hypervisor. PC is Prism Central, of course, for multi-cluster management. And finally, NFS, the Network File System Protocol, which is super critical for how we expose storage to hypervisors like ESXi. So, why does Objective 4.6 actually matter outside of just passing a test? Well, the real-world stakes are huge. Mastering these specific settings is what ensures your clusters can self-heal without any manual intervention if you have a catastrophic node or disk failure. It's also what allows you to securely share storage across different cluster boundaries using elastic VM storage. Seriously, if you get this wrong in production, you are literally risking complete storage outages or opening up massive security vulnerabilities.
Moving right along to Section 2, Whitelists and Sharing. Let's do a step-by-step walkthrough.
Say you want to use elastic VM storage to share a container from one Nutanix AHV HCI cluster with VMs on a totally different cluster. You can't just flip a switch and hope for the best. You have to strictly meet 4 conditions. First, both the compute cluster and the storage cluster have to be registered to the same Prism Central domain running version 7.5 or later. Second, both sides got to be running AHV. Third, and definitely flag this one for the exam, the round-trip latency between those clusters has to be 5 milliseconds or less. That is a hard limit. If it's higher, VM creation will outright fail just to prevent terrible performance. And finally, you have to have a data services IP configured via Prism element to handle all that cross-cluster communication. Now, this part is absolutely crucial for security. When we talk about file system whitelists or allow lists, we are explicitly defining which IP addresses can access your container over NFS. And if you set this at the container level, it completely bypasses and overrides any global allow list you might have set up. But here is the massive kicker you have to remember. There is zero user authentication for this NFS access. None. Putting an IP on that allow list grants immediate, full read and write access to the data. It's an all-access pass. A great concrete example of this in the real world would be permanently configuring a specific IP address so your third-party backup vendor can directly access the storage container.
All right, Part 3, Reserving Capacity and Protecting Your Storage Space.
You really have to understand the distinction between these two concepts because they sound kind of similar, but they solve completely different problems. On one side, we have logical reserve capacity. This is all about protecting one specific storage container. It basically guarantees a minimal amount of capacity just for that container so other containers in the same pool can't come along and eat up all the space. On the other side, Rebuild Capacity Reservation is a cluster-wide insurance policy. It ring-fences capacity at the cluster level so that if a node, block, or rack fails, the cluster already has the exact room it needs to automatically rebuild data and self-heal.
When you're actually setting up that logical reserve capacity for a container, Nutanix has a few very strict best practices. For starters, only use it if your storage pool actually has multiple containers in it. Doing this for a single container is completely pointless. Second, never ever reserve more than 90% of the total space in the pool. And lastly, when you're doing your math, don't just add up the sizes of your VMs and call it a day. You have to budget an extra 10% or more on top of that for data that hasn't been garbage collected yet. Background tasks need room to breathe, right?
And looking at rebuild capacity, the mechanics are actually brilliant. When you toggle this on, the system looks at your fault tolerance and your failure domain, let's say a single node, and it reserves that exact amount of space by literally removing it from the available storage pool. That guarantees self-healing and always finish. Now, because it's subtracting from your total usable capacity, it introduces a brand new metric you'll see called resilient capacity. Oh, and one massive operational detail you cannot forget. You have to ensure the cluster only has the default storage pool before you enable this. Once it's turned on, creating additional storage pools is simply not supported.
Section 4, Common exam traps. This is where you really need to pay attention so you don't get tricked.
Exam trap number 1 is all about how you configure that file system whitelist. Remember earlier when we emphasized that there's no user authentication for NFS because security is entirely IP-based? Nutanix explicitly tells you not to use subnet masks like 255.255.255.0. Doing that would open up full read/write access to a whole block of IPs, which is a massive security risk. The correct, exam-approved method is to lock it down to a single IP address using a 255.255.255.255 net mask. Always choose the single IP option.
Trap number 2 is all about that warning message you see right there. Once you enable rebuild capacity, your cluster operates against that new resilient capacity limit. Do not miss this. If your usage actually hits that resilient capacity limit, the cluster stops accepting write requests entirely. It doesn't just throttle or slow down, it hard stops. That can cause an immediate VM outage. The system is programmed to fiercely protect that rebuild space, no matter what.
Trap number 3. This is a very subtle math trick they love to pull regarding the recycle bin. So normally the recycle bin auto-disables when cluster usage hits 5% of the total usable capacity. But, like we just talked about, enabling rebuild capacity shrinks your available storage pool, changing total usable into a smaller, resilient capacity number. That means that 5% threshold is now calculated against that smaller, resilient capacity limit. Because 5% of a smaller number is smaller, the recycle bin is going to auto-disable a lot sooner than you might mathematically expect.
And trap 4, these are your operational edge cases. If you get a scenario question, keep these strict boundaries in mind. First, never try to modify your failure domain using APIs when rebuild capacity is already enabled. Just don't do it. We already covered the rule about no new storage pools. Here's a really sneaky one. If a node goes offline or is in maintenance mode, updating a file system whitelist will actually fail. Why? Because the cluster can't update the IP table's firewall rules on a node that's down. And finally, if your cluster is running Hyper-V, you flat out cannot create a replication factor 1 storage container. It's just not allowed.
All right, bringing it home with Section 5, Key Facts to Memorize, our final review checklist.
Seriously, take a mental screenshot of this slide. These specific numbers and protocols are exactly what will separate a pass from a fail. Cross-cluster shared container latency must be 5 milliseconds or less. Whitelists demand a 255.255.255.255 single IP mask. Logical capacity reservations should never exceed 90% of the pool. Rebuild capacity shifts your critical storage threshold from total usable to resilient capacity. And lastly, know your protocols for the exam. ESXi natively mounts containers using NFS version 3, while Hyper-V mounts them as an SMB share.
I'm going to leave you with this scenario to ponder. Imagine your cluster has rebuild capacity enabled, and the failure domain is set to node with a fault tolerance of 2n/2d. So the first node fails, and the rebuild completes successfully. A second concurrent node fails, and the rebuild completes again. Awesome. But what if a third concurrent node fails? Does that reserved capacity save you then? The answer is no. The rebuild process only completes if the fault tolerance dictates it. That third failure breaks the fault tolerance math completely, so the rebuild won't complete. Keep digging into those failure domains, trust the structure of what we've covered today, and you will absolutely crush Objective 4.6.